Oh, hi. The papers are officially out. Gauss 2025, grade 7 and grade 8. And we're going to go through some of the problems in the next couple of videos. We're going to start with grade 7. As usual, we just go all the way to the beginning of the second part. In problem 11, which says we have 2 points. The first point is plotted here. The second point is not on the graph, but we know it is 7, 0. Do you really need to plot it? Probably not. How to move from the starting point to the end point? Just, x coordinate plus 5, y it's minus 6. So it's 5 to the right, 6 downwards. 5 to the right, 6 downwards, E. Okay, here we go. So number 11. A train stops at Waterloo Station every 3 minutes. A bus stops at this station every 5 minutes. And they both stop at Waterloo Station at 6:25. And the next time they both stop at this place would be 15 minutes after, 15 is the lowest common multiple of 3 and 5. So after 15 minutes, which is 6:40, both the bus and the train will arrive at the same time. So the answer is D. The next problem is number 2025, 4 digits, 2025 are repeated this way, just a periodic sequence, and the total of 50 numbers are written, and how many of them are 5? So if 50 is divided into groups of 4, that would be 12 groups and remainder 2. Remainder 2 doesn't matter because we are talking about 5 and the two numbers and the 2 leading numbers are 2 and 0. So it's just the 12 groups and there's a 1 5 in each group. So that would be 12 total 5's. Answer should be C. So far so okay. 14. What number goes into the box? So this is a 4 over 32, simplified is 1 over 8, so it should be E. This is a easy one. The next one, problem number 15, 2 standard 6-sided dice are rolled. And if the 2 numbers on the top faces are added, which of the following sums is least likely? So actually, if you want to do this kind of strictly, you should realize that every combination has the same probability because it's kind of a uniform distributed. For each dice, you get the even chance of getting 1, 2, 3, 4, 5, 6. So the chance would be 1 over 6 for any number. And any combination hence would be 1 over 6 to the power of 2, which is 1 over 36. So every combination has the same probability. So if there's a number with the least probability, this is actually the number with the least possible combinations. So let's see. For example, 7, you can get 7 with many combinations, right? 1, 6, 2, 5, 3, 1, 6, 3, 4, and that's too many. This one is still quite a lot, like 3, 5, and 2, 6, 4, 4. And how about this one? This one is like 10. So you can do 4, 4, 6. You can do 5, 5, or you can do 6, 4. It's 3 combinations. So it's substantially fewer. For this one, it's just 6, 4, 6, 5, and 5, 6. You've got only 2 possible combinations. So this probability is quite low. Actually, this is just a 2 out of 36 simplified as 1 over 18, but you don't have to do computation. You just need to realize that, okay, this one has got the least number of possible combinations leading to it. So this would be the correct answer. 11 is the least likely number. That's for this problem. And then it's a problem 16. Each of the digits is placed into one of the boxes, and how can you try to attain the greatest possible result? So, okay, you can think about it. You can say that, okay, the 10th place is more important. Okay, that's it. But if you really want to do it strictly, you'd better write something down. So the thing is like this. Okay, I'm gonna copy everything, don't worry. We've got box, box, minus box. It's a plus box, box. Finally, it's minus box, box. And we want to maximize this thing, right? And the number we've got on hand is 1, 2, 3, 6, 7, 8. I've just ordered them. They are not ordered in the original paper. So I say this is A, this is a B, this is a C, this is D, this is E, this is F. Of course, I'm not saying that you should do this on the exam. I'm just saying that if you want to play safe and want to kind of strictly show the process, this is the way of thinking about it. So this would be minus E, 10, and the rest would be B plus D minus F. So you know these two groups have the same structure. However, this one has more weight. This one is 10 times. So we should make this one as large as possible. And then when this is settled, we move on to this part. So this is a secondary. How to make the first group as large as possible? Needless to say, you put 7, 8, and 1, right? Two of the highest numbers and one lowest number. And the order actually doesn't matter. You can do 8, 7 or something, 8, 7, 7, 8. It doesn't matter at all. So actually, it doesn't matter which numbers you put in these boxes. You just need to consider them as a whole group. And the rest numbers are 3, 6. Okay, so it's just a 3, 6, and minus 2. And this would give you 140, and that is 7. So the answer is 147. So let's have a look. 147, we do have this as one of the choices, so it's C. And let's go back to this. Again, I would say intuitively you would say, okay, I just put large numbers into these two places and the smallest number over here, so the 10th place is most important. This is intuition, but if you really want to see that intuition clearly, you can write something like this. And if you were doing a more complicated problem, this is something you need to do. That's everything I think for this problem, but this problem proper is not actually a hard one. And then problem number 17, just go tossed a fair coin some number of times, and 50 of these tosses resulted in tails, so it's right now half. And then she tossed the coin one final time, so just one more time, and that is a tails. So after that, 50 this time it's a 60%, right? It's because you've got one more tails, and 60% of all tosses are resulted in tails. And how many tosses did she make in total? Many different ways of doing this. You can do this mental if you want, but let's say let's say you're too nervous and you can't work your very well work your brain. So just to do it the regular way. So the regular way is to translate the problem into some algebraic expression and see if you get equation or something. So initially we've got, let's say, x tosses and x tosses head and x tails, because it's 50-50. So it should be x and x. X is the number of tosses that is made to get this result. And then one more tail is get, and this is a 60%, this is a 40%. Okay, so we can just do this. You don't have to think too much, just to give the equation. This out of total is 60%, meaning simplified as 3 over 5, and solve the equation, butterfly 6x and 3. 6x and 3, so x is 2. Once you have found out that x is 2, you just plug it back in. You see 2, 2, 1, that is a total of 5 tosses. So the answer should be this, 5 tosses in total, D. Yeah, that's it. Okay, problem number 18. 4 of the angle measurements, 4 out of 5 are the measure of the angles in the same quadrilateral, and which angle measure should be kicked out? So you know that the total is 360. So which 4 numbers can add up to 360? Of course, you can look at them and try a bit. But a better way to do to solve this problem is doing subtraction. You do minus. So you add them all up, and then you minus 360. The rest number would be the number that should be kicked out. And do you really need to add them up? That's a lot. But you just need to look at the last digit. So it's 25, 25, 7, 7, 9, 6, 6, 4, 0, and 8. So you know, the last digit is 8, and then you just do minus 360, so the last digit is still 8, meaning the number that should be kicked out would have last digit being 8, which is 108. Since it is a multiple choice question, you know one of them should be kicked out. You can do it this way. Unfortunately, they all have different last digit. So this way actually works here. If it doesn't work, it doesn't matter. You just add them all up. I mean, brute force addition and then minus 360. You still can figure that out. It's not actually a it doesn't actually matter much in the from a math perspective. But if you really want to speed up on the exam, you can just look at the last digit, and this should take no more than 10 seconds for you to solve this problem. Anyways, the answer is the 108 with the last digit being 8. And this is a problem number 18, and we've got 2 more for this part. Okay. This problem, number 19, 10 students each receive a number. The number is from 10 to 19. So basically, we've got 10 numbers, 10 to 19, and then we're gonna do a kind of a survey checklist, let's say. If it satisfies, you just check, okay? And how many students check off exactly 2 boxes? Exactly 2. Okay, so please calm down. You can do, I mean, if you do not calm down, you just try every number. You just do this checklist for every number, and then you count how many of them get 2 boxes checked off. However, if you really think about it, you will notice that a number is either an odd number or an even number, and the number above 1 is either a prime number or a composite number. That is to say, we must check off 1 here, and we must check off 1 here. So actually, the first 4 items doesn't matter. You always check 2 out of the 4. So the only thing you want to make sure is that the last box is not checked. The number should not be a perfect square. That is to say, 16 is the only number that you should kick out. So we've got total of 10, and 16 is out. So the rest would be 9 numbers. So the answer is B. Without any computation, you don't need to write any number out. Just some logical reasoning gives you the quick answer. And this is not shortcut. This is actually, I guess this is what the problem maker won't expect the students to do. But yeah, I think, but if you're really desperate, you can just list all numbers. That still works. And maybe after doing this for 1 or 2 numbers, you will realize that there is such a pattern, and you don't actually need to do all numbers. That's also maybe part of the purpose of the problem makers. Who knows? Okay, but anyways, let's move on to the last problem. In this part, 3 in this diagram, so the diagram is already given, and 3 corners are 60, 60, 60, and this is a 10, this is a 6, and that's all what we know here. And we need to find the perimeter of the strange shape. Okay, so the total perimeter. How long would you have traveled if you walk around this shape? And easily you're gonna cut it this way. Okay, you're gonna cut it this way, and this SR thing, the segment. Although we do not actually know how long it is, it doesn't matter. You can just push it in. After pushing it in, SR is moved over here, and then you have a equilateral triangle, and you have a 6 and another 6 because after you pushing it in, this is a parallelogram. However, if you really want a strict proof, you should do it this way. You extend, let's say extend PT, so that it intersects QR at some point. Let's say this point is M. It doesn't matter. The name doesn't matter. We don't even need to call its name. But we know that this corner, this angle would be 60 because it is the internal angle, and this is 60. This is a 60. So the third internal angle of this triangle should be 180 minus 60 minus 60. So this is a 60. And since this is a 60 and we have another 60 here, and these 2 angles are corresponding, if the corresponding angles are the same, these 2 lines are parallel to each other. And also the problem says that these two lines are parallel to each other. This is already given in a problem. So we have two pairs of parallel lines, which gives the definition, which fits the definition of a parallelogram. That is why they are. This is a parallelogram, and since it is a parallelogram, you can know that this is one of the properties of a parallelogram. Opposite sides are of equal length. So this SR can be pushed in, and we can tell that TM and SR are the same long. This is really a strict proof. Which is a bit lengthy. It's not actually trivial. However, if you are sitting in an exam, no one is expect you to do this. You just use your intuition. Push this in. You know this is an equilateral triangle, so the total would be 30 over here, and for TS and MR respectively, it's 6. So 6 and 6 is 12. 30 plus 12, that would be 42. 42 is A. So the answer is here. Yep, that's it. So actually, if you just want to do it intuitively, maybe just 20 seconds and the thing is done. But if you really want to give a concrete reason, you should have gone through all the lengthy proof. After the exam, if you are not sitting in an exam, if time is not an issue. So that's it. It's not a hard problem, and that is all for part B.